welcome to lecture 89. So, we have done one problem related to interplanetary transfer. So, you might have got an idea what is happening. Now, we will put the whatever the processing we have done in terms of mathematics. So, let us start with so the two planets are shown here. This is one and this is the reference line we take, reference line. So, planet 1 and 2 they are in the inner and outer orbit, and let us say n 1 is the angular velocity in this and n 2 is the angular velocity in the outer one. So, n 1 in inner orbit, angular velocity, and n 2 in the outer orbit, in outer orbit, angular velocity. So, with the reference line, the angle for these two planets, it can be written as n 1 t and theta 2 equal to theta 0 2 plus n 2 t. So, these are the position which is very simple, okay. And theta 2 minus theta 1 therefore, can be written as theta 0 2 minus theta 0 1 plus n 2 minus n 1 times t, which we can write as phi 0 plus n 2 minus n 1 t, and on the left hand side we can write this as phi. So, phi equal to phi 0 plus n 2 minus n 1 t. Phi is called phase of or phase angle of planet 2 with respect to planet 1, and phi 0 is initial phase, that is at t equal to 0. If n 2 is greater than n 1, which will happen only if n 2 is lying in the inner orbit and n 1 is lying in the outer orbit. So, if n 2 is greater than n 1, then planet 2 moves anti-clockwise with respect to the planet 1. If n 2 is less than n 1, then planet 2 appears to moves clockwise with respect to planet 1. So, phi 0, this is the initial phase angle. So, the question can be asked. Now, let us take this figure again here in this place. So, this was the position of 1 and this was position of 2, this angle is your phi 0, the difference between them. So, the question arises, when again this phase difference between these two, because they are moving. So, the phase difference will change. So, when again the same phase difference will appear. So, this is the question. So, that means phi plus 2 phi equal to phi 0 when this will occur. So, I will write it in language. If at t equal to 0, phi 0 is the phase angle, then after how much time phase angle will be phi 0 again. So, here phi 0 is indicating the phase of 2 with respect to 1 initially. So, let us consider this in two cases, say the n 2 is greater than n 1, case 1. So, this I will remove, rather than writing like this I will write in terms of equation. So, case 1 n 2 is greater than 1. So, therefore, phi will be equal to phi 0 plus 2 pi. What does this mean? See here, this is the phase of 2, okay, and n 2, if suppose n 2 is faster than the n 1, okay, it is a greater than n 1. So, when the same phase will come, for this it is required that with respect to this, with respect to 1, obviously 1 is also moving. So, while it moves in the orbit, so with respect to 1, it has to go all the way from 2 is here. So, it has to go all the way from here and again go back to this place, means the 2 pi angle it has to cover. So, that means the phase angle of 2 with respect to 1, this becomes phi 0 plus 2 pi at that time. Okay. This is moving, this is 1 is also moving, 2 is also moving here in this direction, but 2 is moving faster, of course, which is not the case. Once 2 is inside only that will happen, but let us suppose that it is written like this. So, starting from this place and going back to this place. So, total phase angle with respect to 1 then becomes equal to phi 0 and plus 2 pi, and this must be equal to phi 0 plus n 2 minus n 1 times t, and the period after which, after how much time, this period, this is called the synodic time. Same as the moving reference frame, rotating reference frame we have done in the restricted 3 body problem. Okay. So, this is synodic. and therefore, from this place what we can see, this T synodic, this will be equal to 2 pi n 2 minus n 1, provided n 2 is greater than n 1. The case B can be case B or 2, n 1 is greater than n 2. So, if n 1 is greater than n 2, then 2 will appear to move in the backward direction. Okay. If n 1 is greater than n 2, so with respect to 1, the 2 will appear to move in the clockwise direction like this. So, therefore, the angle to be covered in that case, it has to go from has to start from this place. Okay. It will go here in the back direction. So, here in this case, this will be phi equal to phi 0 plus n 2 minus n 1 times T synodic. This will be equal to phi 0. So, it starts from this place, it goes all the way here in the negative direction and then comes back. Okay. So, at that time the phase angle, this becomes phi 0 minus 2 pi. This is in the opposite direction, this 2 pi. So, it comes to the same phase again with respect to 1. Okay, and once we solve this, so the T synodic, this will be minus 2 pi divided by n 2 minus n 1. So, both can be combined together and the T synodic can be written as 2 pi divided by n 2 minus n 1 magnitude. And this is very important, because this tells you, because as you have seen that before launching certain conditions should be satisfied. The phase angle between the planet A and planet B, it should have a particular value. So, that if you are launching the satellite from planet A to planet B, so your satellite goes through 180 degree of Hohmann transfer. Okay. This condition has to be satisfied. So, this particular condition, this phase angle difference between planet A and planet B, when it will occur again. Okay. So, once you miss that time, then you have to wait. So, how much time you have to wait? It is given by the synodic time. This is the waiting time if we miss to launch, so that phase condition is matched, is satisfied. Okay, so, we have looked into one aspect. Now, we go for the round the trip mission in terms of mathematics, round trip. So, a forward journey, one is here, 2 is here, this angle is phi 0, the phase angle difference. and then from here the launching is done. So, if in this condition one has to go and catch up with 2. Okay. So, if we launch the satellite at this time, so using the Hohmann transfer, so it will catch up 2 here in this place. So, this is 2 prime, it comes to 2 prime. So, initial phase angle condition should be matched. Okay, so, in our case this phi 0, the earlier problem we have done, this is corresponding to the initial angle was given, which was 139 degree for one, and the other was 271 degree. So, 270 minus 139 and plus the wait time which we have used, okay, and plus the wait time, that makes your phi 0, and then you will be able to launch. So, that in that time the 2 goes from this place to this place. Okay. So, here this time will be 2 times the time of travel n 2 t. So, we can write the equation now. So, pi 0, this quantity, then this is related to this whole angle is pi. So, pi minus, and this angle is from here to here, this angle is n 2 t. When the spacecraft arrives at 2 prime. So, at that time phi f is the phase angle, and this quantity will be phi 0 and plus n 2 minus n 1 t. So, this is the time t. So, during this whole flight is taking place. So, therefore, the phase angle difference, it will be given by the initial phase and plus n 2 minus n 1 times t, the angle between these two vehicles. So, one will be at that time, because phi 0 is the initial phase angle here, this is your phi 0 which is shown here, and then n 2 minus n 1. So, velocity, angular velocity of 2 and angular velocity of 1, this we have to subtract, and this flight time how much it will go ahead. So, this will show you where your the second one is lying with respect to 1. This is the angular difference initially, and later on this much of angular difference between 1 and 2 will be created. So, phi f, then this becomes pi minus n 2 t plus n 2 minus n 1 t, or phi f equal to pi minus n 2 t cancels out, n 1 t. Because 1 is faster, and therefore, this phi f will turn out to be negative. So, this same thing we can write here in this way also, this is n 1 t minus pi. So, when the spacecraft arrives at planet 2, phase angle will be given by phi f equal to pi minus n 1 t, and this is very important. And if you refer to the our earlier problem, so the initial phase difference we have calculated somewhere. See the initial phase difference this is the quantity we have calculated. So, this is the initial phase difference between these two, theta b prime and theta a, between the planet A, asteroid A and the asteroid B. So, this is referring to the phase difference we are writing here. So, this is written more in mathematical terms. Sometimes it may happen that you do not remember the equation, but you can always work out using the problem the way I have solved it. Now, during the return journey, so this is for the forward journey. Okay. Remember that here your wait time is included in this. Wait time or initial any offset of 1 with respect to 2, this is everything is included in this phi 0, which we are calling as the initial phase difference. Okay. Do not mistake this with the previous problem. Here we have combined both of them. So, return journey. Return journey we can just write by matching the angles. So, phi f the initial phase difference and then n 2 times t w. So, now the same thing happens in the return journey, you have to wait for certain time. So, this we are writing as the wait time, the waiting time. You cannot immediately get back from planet 2 to planet 1. Okay. So, n 2 times t w, this is your angle covered during the waiting time by 2. This is for on the left hand side, this is planet 2. Okay. So, initial phase difference, say here either on the back direction, on the front direction, whatever it may be. Here in this case, let us show this as phi f, and then the waiting time goes. So, waiting time here is in this case is separately shown n 2 times t w, and then from here the satellite is being launched. So, the angle covered, this is pi corresponding to this. So, total angle covered from this place, measuring from this place, this is the position of 1, this is the position of 2 here initially, this goes to 2 prime. Okay. So, during this time your 1 is here, and 1 during this wait time it will travel to say somewhere, it travels maybe because it is a faster. So, it may travel to this place, it may go all the way from here and it can come to this place, and then from again for in this time which is corresponding to here T w, sorry, this is the flight time which is corresponding, this is the flight time t, okay, and which is corresponding to angle phi. So, that means where the earth has to cover certain distance such that your angle is matched. So, here we write this as phi, we will return back to this. So, n 1 times T w plus T plus minus 2 n pi. Let us look here in this quantity first. What this is? N 1 times T w plus T. What is this? N 1 times T w. T w corresponding, this is the, this particular part, this segment where the time T w, which is the waiting time, this and plus the T time. So, during this time T w plus T, how much one is will be covering the angle. So, it will go from all the way at the angular speed of n 1 multiplied by. So, this is the angle this is going to cover, and this must be lying opposite here in this case, if it has to catch the spaceship in the return journey. So, the angle, this is angle covered by 1. So, angle covered by 1, it is a getting back maybe one rotation, or as I have written here, this is plus minus, this is plus and minus. It may go a number of times, but it has to come back to the. So, if it is going number of times, so for this plus minus sign has been added here to n pi. N is the number of time it goes there. So, n equal to 1, 2, 3 and so on. So, this is angle covered by 1 and plus minus 2 n pi. This part is angle covered by 1, and this angle must be equal to phi f, which is written here, plus n 2 times omega, this angle. So, you can see here it starts from this place to the, if we just look angle wise. So, it goes to this place, and from here the launch is being done. So, this is the total angle covered, and this we have to add to phi f. So, phi f plus n 2 T w plus pi, this should be equal to this much, and thereafter if we rearrange. So, n 1 T w, this will be equal to minus pi minus phi f plus minus then n 1 t plus n 1 t and plus minus 2 n pi. Pi minus n 1 t. So, pi minus n 1 t, already we have this value here, phi f equal to from the previous derivation. So, this is minus f minus phi f plus minus 2 n pi divided by n 2 minus n 1. So, T w, the wait time is then minus 2 phi f plus minus 2 n pi divided by n 2 minus n 1. Okay, other way also we can derive this equation expression, where whatever the problem we have done mathematical one. Okay. If you follow that notation, add all the angles, you will get the same result. only thing that you have to add here plus minus 2 n pi, and this is to make this quantity positive, and n is chosen in such a way. So, this is 1, 2, 3, 4 like that. So, minimum of that n has to be chosen, okay. So that this T w remains positive. Here this T w has to be, this is a positive quantity, because it depends on n 2 minus n 1. Okay. If n 2 minus n 1 is greater than 0, so this the denominator becomes positive. So, accordingly we need to adjust here. Okay. If this is negative, okay, so then you can see that what the result will be. So, this accounts for your the wait time in terms of mathematics. So, I will suggest doing the problem the way I have done, okay, and to that you can always add this quantity plus minus 2 n pi. Just like if you remember, I have subtracted 360 degree, that means I am subtracting minus 2 pi. So, minus sign I have taken there. So, if many times you are not able to visualize, then you can just take help of the equation and then work it out. So, to wind up this particular part, what we have done, we have taken the planet 1, and the planet 1 in the wait time T w, it will move by n 1 times T w, and then during the flight time it will move by n 1 times T. So, I have added this, and to this plus minus 2 n pi I have added, because the planet is faster. So, it can go many times. Okay. The more faster it is, the more number of times it can go. Okay. So, this quantity, then if it is going many times, immediately you can see that you have to subtract. If it is slower, n 1 is slower as compared to n 2, then you have to add plus 2 n pi. So, here subtraction is required. On the left hand side, what we have done, phi f is the initial phase difference between 1 and the 2. During the wait time, further phase difference is created. Okay. So, this comes here, and then to this we add this pi angle, which is the angle from this place to this place. So, that it matches with the position of the earth. In here, in this case, say this is the earth, A is your earth, and this is Mars. Okay. So, this way the angle can be matched. So, the same problem what I did using the mathematics, the same purely the numerical style. Now, here this is theoretically this is done. Okay. So, we stop here and will continue in the next lecture.